Hello, and welcome to CSIT1100 Principles of Computing. My name is Jacob Elmore, and I'm the Assistant Professor of Computer Science at Graceland University. This course is an introductory course in computer science, which means we're going to approach the ideas of computer science in a way that hopefully is welcoming and friendly to anybody, regardless of your background with computing. We're going to be talking about what computing is and what computational theory is, what computer science is. We'll talk about computer programming and how this action relates to the study of computer science. How are they similar and different? We'll introduce a new way of thinking that allows us to solve problems in a way that's more easily translated into a computer program. This is called algorithmic thinking. And we'll discuss different algorithms for solving common problems. We'll talk about information and data, how we can retrieve information, store and manipulate, and use data to help us solve those problems. And finally, we'll talk about computer graphics and how we can use computer graphics to create an interface between users and the underlying computer program. There are a number of tools we'll be using for this class. Primarily for your programming assignments, you'll be using Python 3.5.1. You can download this at www.python.org, and we'll go through how to install this on your machine in a later video. Periodically throughout the course, we'll have meetings where we work on projects together. For these meetings, we'll use codeshare.io. This is a website that allows us to write code in a way that both users or anybody who's present can contribute. And lastly, the textbook for this course is called How to Think Like a Computer Scientist. You can find this textbook at Runestone Interactive at interactivepython.org. You can follow the link in the video or in the slides. Now, the outline for this course starts with an introduction, and then later on we'll talk a little bit about some simple Python data. We'll talk about how we can give data to the computer, perform some basic operations on it, and then output data from the computer after we perform these transformations. We'll talk about basic debugging, which is how do we find and fix problems in our code. Week 3, we'll move on to Python Turtle graphics. Turtle is a simple graphics package that allows us to create artwork and other unique designs using code. In week 4, we'll move on to modules and libraries, which is how we bring in code from outside sources that allow us to create some really complex and interesting programs in Python. In week 5, we'll talk about functions and how we can use them to logically organize our programs. We'll also talk about the flow of execution and how the computer interprets a program as it runs. In week 6, we'll talk about selection and logical operations, which is how the computer uses formal logic, called Boolean logic, to help create more intelligent systems and programs. In week 7, we'll talk about iteration and loop structures, which are techniques that allow us to perform computations on larger data sets or in more complex problems. In week 8, we'll finish up before the midterm with a discussion of strings and text manipulation, which is a surprisingly common problem in computer science. After the break, we'll start our discussion with a visit to data structures. We'll talk about lists, which are the fundamental data structure in Python. We'll then talk about two specific or more specialized data structures called sets and tuples, how they're used and what they're used for. In week 12, we'll talk about files and file I/O, how we can, or file input-output, how we can store information on our hard drive and retrieve it later. In week 13, we'll revisit our discussion of data structures with a specialized data structure called a dictionary, which uses key-value pairs to help make finding information more simpler and easier. In week 14, we'll discuss recursion, which is a powerful technique for solving very complex problems with very simple programs. And in week 15, we'll finish up the semester with a discussion of basic object-oriented principles in classes and objects. The course is divided into 5 3-week sections. A minimum grade of 65% is required to pass each section, and all 5 sections must be completed to pass the course. Your total grade for the course will be the average of your grade for all 5 sections. Each section will consist of 3 to 4 chapter quizzes, 6 programming assignments, and a section test. Sections 3 and 5 will include the midterm and final tests, respectively, and those tests are comprehensive. In addition, there will be one extra credit programming assignment in every section, and the points from that assignment can be applied to any section. So it's a good idea to start doing these in advance and save those up in case you need them later. Now, sections are intended to be completed in order, but within the section, students are encouraged to explore and work at your own pace. All of the materials for the section are presented to you, and you can view the videos, work on the homework assignments, in whatever order you feel comfortable with. Now, the lectures and assignment numbering follow the order and the presentation of material in the textbook, and that's generally a good order to pursue them in, but don't be afraid to experiment and find out what works for you. Thank you, and I'll see you in our next video.